So Dom, what should we do today? I guess we're going to start from scratch. Is this literally like get init dot and then go from there?
Let's do it. Yeah, I
Okay.
wanna. I would love to end the next 2 hours with maybe a little, like a ball bouncing. Can we have a GL view and a ball that bounces off walls so we can do our like angle of incidence, angle of attack thing?
That
Is that too much, or is that like a bite-sized chunk?
No, I think that sounds great. Um, so anecdote about making games. I have tried to make a game from scratch multiple times, and I did not respect the rule of like trying to get something on screen as soon as possible.
Hmm.
Um, and so what I ended up with is like a bunch of like really awesome C++ vector libraries. Just like it was like very easy for me to just work on everything except the game itself.
Maybe I'll be the temporary influence because I find the math is kind of boring to me sometimes, and I really want to play the game. So
Yeah.
perhaps I'll be like Jeff. This is boring occasionally.
So yeah, that's totally fine.
Yeah.
The problem with that is that I think if the math is boring for you, that's probably because you're better at me than them with the
No,
math.
no, it's hard. It's harder for me.
Okay.
I'm just like, I don't know what's happening, but I'll be probably really good at 3D calc by the end of this process. So I'm excited.
Yeah.
No, no, I'm bad at
Okay,
math,
doke.
dude. Don't count on me for the math, but I will learn.
Right. Um, I am gonna mention that my iPad has died. I'm not gonna worry about that for now. We're just gonna
Okay.
get right into it. So I can't see your face, so you can make all kinds of funny faces at me.
You can at least put the stream on your phone if you want to have like a little sidecar, like
Yeah.
it's all still there. That's what I'm doing.
Yeah. What I might do is just stop hiring and just not burn the CPU cycles,
Oh yeah,
and
kill the iPad.
I'll go from there. Okay, so we're gonna make the game.
Yes. Whew,
It's a Git repository,
I love it.
and then what do I do? npm init is that the incantation? Should I be using yarn? What should I do?
Um, God, I think it's npm init, and then you can use yarn on top of that. But this just makes a package JSON for you. Whoa, we're doing dependencies on the
Um,
stream. uh, oh,
I do have Node.
I don't think you want a dot. Just npm init.
That was the problem.
Hmm. Also, I think the white box of my face is back on the screen. Can you minimize that?
Okay, I will do that.
It's just a white box on the stream. That's weird.
Yeah. Do you have which desktop do you have? Is it my Slack window
I'm seeing you
or is
swiping
it
back and forth. I have your
you're seeing me
full
swipe?
screen. Yeah.
Oh my god. Okay.
Yeah, I don't know if you can share a window, but if you wanted to share like the terminal, that would be different. But like, nah.
GitHub.com. Believe it was called Jeff and Dom,
Mm-hmm.
the game. ISC license. You're comfortable with that?
I'm comfortable with that.
Okay. All right. Okay. And then we're going to get, I believe I already have Parcel.
Mm-hmm. But you might as well do yarn add parcel if you want to like get it all in there.
And that will add it to my local package.json.
Mm-hmm. Yep.
Great.
And then yeah, then we can do like yarn start and do the start script, and it'll all be parcel. Thank you for indulging my yarn habit.
I love it. I need those emoji. Does anybody have emoji?
I don't know, but that's how you know it's fun. Just like Ruby.
Right.
Sweet. Wow. There's a lot of dependencies in there.
what is all of this? It's crazy.
I never want to know a node. If left pad is probably still in there for all we know.
I bet it is. I don't know. Okay. Let's get something on the screen, shall we? Is it parcel in it? Let's see. It's been a little while.
So I think if you make an index.html, it's just parcel index.html to get it started, right?
Okay. So let's open up the game. I just installed VS Code.
Nice.
I find it to be slightly better
Adam.
than Sublime for at least for TypeScript.
Okay.
And let me actually just study let's check out the structure of the project that I had already started, just so we're not just sort of flailing around too much.
Oh, yeah. That seems super reasonable.
So yeah, I have a repository game.js here. We've played with it a little bit in the past. It has dodecahedrons and X-wings, rotating, revolving, and scaling as well. But it's not really a game. I guess the name of the repository is a bit of a misnomer. So it looks like the structure I have here is basically a HTML file, and it has a pretty minimal style sheet for just getting rid of some padding, and then it just loads the main.ts file. And none of this is actually going to be seen by the browser. I think this is all kind of like pre-processed by Parcel into something a little bit more exciting and interesting. Yeah. So let me go ahead and just I hope you don't mind if I just copy this.
I don't.
Okay.
I used to have a macro where I would just type HTML and tab, and I would get that in a document. But it's been a while.
You get this whole thing.
It was with a couple more things for Rails, yeah.
Yeah. Okay, so.
Sweet. So if we make a main.ts and do a console.log and run parcel and index, I think it just works. Or that is the Parcel promise.
Main.ts. And let's just take a look at what we've got here. Yeah, I think all we really need to be able to do is just, let's prove to ourselves that we can update the canvas. How does that sound?
I can do that, yeah.
Okay. All right. So we're making TypeScript. It's incredible. Okay, so what's a good way? Let's make the canvas. How do we paint a canvas?
It's great that we both have to Google this because I don't know the command for it. But I'm really glad you typed MDM first there because that's how you get stuff.
Right. Worklet. Maybe paint was the wrong thing to search for. What I really want is, why don't I just attach a div? Is that possible? Create div.
Oh, yeah.
We're going to add that div, and then can I do div.innerHTML or something like that?
Yeah, totally.
We're getting something on screen.
I'd expect that.
And then
just parcel index.html should do it.
Oh my god.
Dude, I'm a big Parcel fan. It installed a lot of dependencies, but that was longer than 7 milliseconds, though. I'm just going to throw that out there. It's fair shit.
I'm pretty sure it started measuring like probably long after I stopped typing, right?
7 milliseconds before it finished. It was like, hey, that took 7 milliseconds.
Yeah. So I think this worked. Either that or this is just hard-coded to say hello world to us,
you
right?
could say hello, Jeff and Dom, if you wanted to really test it. They couldn't have hard-coded that.
Yeah. No, absolutely not. Oh, and look at it, hot reloaded. That is magic.
We drag this tab over to the editor screen so we can do a little less back and forth slidey slide.
Okay.
That's the only thing I'm seeing sort of lag out on my screen share.
Yeah. So here we go.
Yeah.
Okay. Great. Sorry, I'm a little bit of like a full screen window kind of guy.
Dude, I feel
so. Okay, but I can kind of tab back and forth, and that should be reasonably
that's a lot faster
visible.
than this. Yeah, this way.
Okay. Fantastic. All right, so we need to do some OpenGL. So this is going to be a lot of us sort of flailing around reading documentation, or maybe you can tell me what to do. But we did actually want a canvas element, right?
We want canvas.
And a canvas is basically just a pixel buffer in an HTML document. Is that how you understand it as well?
Yeah, and you can address it pixel by pixel, and somehow you can. I guess with the OpenGL, we're running WebGL and just giving it the canvas as our viewport to write to. Is that essentially how that's working.
Yeah, I believe
Gotcha.
that's correct. Yeah.
So I
Um,
was confused as why the canvas is even part of the WebGL stuff, and I realized that it's just like the display output for it.
right. Do we want to start with maybe like a black background?
Yeah,
How does that sound?
let's do that. Um,
And
are we gonna do
we'll
that? Are we gonna do Three.js or OpenGL from scratch? Probably from scratch, right?
let's do it from scratch first. I'm happy to use Three.js. I've actually never used it before, but I'm happy to dive right into that if we feel like it ends up being a little bit easier.
Okay.
But just for my own re-education, I've done
Yeah,
this before, probably like a couple times in the past, and I forget how to do it every time. There's like a bunch of incantations that we have to recite.
that's my recollection. Yeah,
Um,
you need to like init the context and set up like a series of shader pipelines.
yeah,
Even to
we
make
might
like
not need a shader just to blank the screen, but it'll get there, right?
okay.
So, a couple things I'm copying here.
Mhm.
Um, this is pulling out the WebGL2 context from the canvas.
Mhm.
Um, it's interesting that this is singular. Um, so there is one GL context per viewport, which seems a little bit weird to me.
Hmm.
I would have assumed that the context would be independent of the viewport, so you could render multiple GL contexts into the same viewport, but you know what? I'm not going to quibble with this too much. We're just trying to paint a black screen on,
Yeah,
and so we
for
probably
what
don't
it's
need to get
worth,
too crazy here.
I'm grateful the browser gives us one GL context, let alone like
Yes,
multiple. So I'll allow it.
right. Okay, so we go ahead and just copy some of this stuff just because I feel like it's like a little bit boilerplate, right? But
Mhm.
we maybe want to understand what's going on here. Um, so I'm already starting to use like a vector library, which I don't think is 100% necessary. It looks like what we really want is
That's
just a width and height, which
Is
we
this
are
like
initializing to the window size, right?
isn't that yeah? That's a funny vector because I'm like that vector is like the identity vector for the finger setting.
um, I don't think we needed the vector. There might have been some moment where this was passing in parameters in the past or
Oh
something
well,
like
you
that.
know what it is. I assume that when I get to draw, I assume this actually wants the vector. Um,
Oh, I see.
is
Yes,
probably
that
the reason.
requires. Yes, I think that's probably what it was.
So maybe let's just comment
So,
out those lines so we have a memory of that.
okay. So what this is doing is it's just setting the canvas's size to the window size, um, and then calling that when. I guess this event listener technically is a little bit ahead of our game here. This is like if we resize the window, the game itself will scale with that.
I'm
Does
okay
that make
using
sense?
that. Yeah, that feels like I've made a website before. I know where that goes.
Okay. You're okay using that or losing that?
Losing it. I'd like
Okay.
to
We've lost it.
yeah keep it a little light going on now.
It is dead.
Yes.
Okay. All right. And then now we get to do the fun renderer part, which is going to be a little bit intricate, I think.
Mm-hmm.
So this has some shader compilation and program linking, which we're definitely going to get into tonight.
Mm-hmm.
But just to get something on the screen, let's get some colors on the screen. And I believe all we need, there's probably just like a function we can call that'll just do it. Um,
Is it clear color? Yes.
GL clear color.
I remember that.
And I think GL is exactly that canvas object, that context object, right?
Mm-hmm.
So, yes.
So it should be black now once you switch back to our. Oh, should be.
We're going to check the console for any errors.
Mm-hmm.
Maybe this is an area where I did need to restart. I don't know, man.
I'd be surprised. Where's the console? Did you open the console? Oh, there it is. Okay.
There it is.
Can we inspect? Yeah.
Canvas is there.
Okay, so that means our viewport size is set. So
Yeah,
something
this
about
code's
the
running. This
yeah
code's running, right?
with no
Um,
errors. Importantly.
yeah. GL clear color. Do we need to do some kind of flush or
Yeah.
some kind
Does
of,
this need to happen inside a
yeah,
transaction or a write of some sort?
right.
Does it need to be clear color then gl.clear, right? Is it you set the clear color then you clear?
Yes, that's right. GL clear color is sort of like inking your brush, but it's not actually applying anything. Very good, sir. And then there might be. What's that?
I was just gonna say every time I do OpenGL, it's always like 3 steps instead of the 1 step you expect.
Yeah. Yeah, it used to be even crazier. Well, I don't know. I guess it's debatable because before we had all these like fixed function pipeline where like a lot of it assumed a lot about the way that you would want it to sort of structure your geometry and that sort of thing. We have a black screen.
Yes. Did I do that? Yes, I can continue
Yes,
now.
you totally can. Yeah.
That's great. Cool. It worked.
Yes, it totally worked. Okay, so now we need to draw. What if we drew a bouncing box rather than a bouncing ball? I'm going to say that rectangles or even triangles are probably easier to do than. Yeah.
Let's go big. Let's use 2 triangles to make a rectangle probably. So like.
I think we can use quads, right? I think we can. There's like a quad drawing mode.
Even better.
But we can use 2 triangles. What are you in the mood for?
No, sorry. Quads. If there's a primitive, let's use the primitive.
Okay. Sounds fantastic. Okay. So first of all, just to talk a little bit about what I just did with this clear function call. You notice that there's actually 2 flags being set right here. The GL color buffer bit. It's funny that the color buffer bit is actually like a property of the GL context object. You would think that this would be sort of like a library global or something like that, but they just stuffed it onto the GL object. Maybe they're using something like a object prototype or something like that, because it seems weird to just like copy that everywhere. But then we're also clearing this thing called the depth buffer bit, which I don't think we'll necessarily get into explaining today. So maybe I'll get rid of that actually. We can kind of, or we can come back to that, right?
If that's optional, yeah, let's leave it off.
Yeah.
That'd be cool.
Dom, do you know what a depth buffer is, by the way?
I don't.
Okay. Well, that's fantastic. We're gonna get to learn together.
I would take a guess that it's something to do with depth mapping, but I'm not sure.
Yes.
Or is it actual z-index? No, I don't.
It's just the quick summary of it is it's the way that we make sure that objects that are farther away don't paint over objects that are closer. And so the depth buffer basically, when you write geometry into the GL context and you give it a perspective, it knows not only the X and Y coordinate of all the sort of like colors and pixels that you're trying to render to the screen, but also knows the Z coordinate as well. And so the depth buffer is, I don't know, however many pixels you have times the number of bytes in a Z coordinate, which I think is going to be just a 32-bit int, or a 32-bit float. And it will always have the, well, this is OpenGL, so I believe the Z gets more negative away from you in OpenGL. I think that is the principle. We're gonna have to basically remember all of the weird OpenGLisms. For example, like is the axis right-handed or left-handed? And I believe in OpenGL, like the Z coordinate gets more negative as it gets away from you.
Okay.
And I mean, it could be it's either that or the exact opposite, right?
There's no third option.
Yeah. And so in OpenGL, the depth buffer will always have the highest or the least negative Z value that has been written to that pixel. And when it renders every pixel, it will do what's called a depth test first and say, like, is the Z that I'm about to draw greater than the Z that's in the depth buffer? And if it is, I'll actually draw the pixel. And if not, I won't.
That's really clever. Cool.
Yeah. Yep. Okay. Because before you had to like do the painter's algorithm, right? You literally had to like sort your geometry in application code and then actually render it, which is a pain in the butt. All right. Let's draw some quads. So we are in OpenGL 2. The nice thing about the old fixed function way of doing this is you could just call a function that was like, give me a quad. However, I think we're in the realm right now where we're going to have to actually construct our own vertex buffers and index buffers and then draw them that way.
How is this an improvement?
You know, I think maybe folks decided that the more minimal API was the better one. It seems like the graphics APIs that are available to folks are getting lower and lower level. Yeah,
That's fair. That tracks with like the Metal release for Apple.
yeah, with Vulkan and those sorts of things. I mean, I only know a very superficial amount about those things, but you know, especially because like I think we're using GPUs now for just other things than just graphics, and so folks I think maybe prefer to be able to just like compile their own stuff into the assembly language of the GPU, right?
Okay, fair enough.
Yeah, but we gotta draw a friggin' rectangle onto the screen right now. Thanks a lot, guys. Okay, so one thing I can do is just look at the render and see what I'm doing here. This render is actually considerably more complicated than what we need because it does that kind of cool 80s wireframe rendering that we don't really need at all right now. So eventually what we are going to need, though, is a combination of things. We are going to need a vertex shader to place the vertices. I'm not actually sure in GL2 what will happen if we don't have a vertex shader. Like, will the verts just go untransformed and then pass directly to the frag shader? So there, in sort of classical triangle-based rendering, you have two layers of shaders. One is the vertex shader, and one is the fragment shader. And the vertex shader consumes your geometry. Its name is vertex because it literally processes vertices one at a time. And yeah, so what happens usually in your program is you have like a set of geometry that you're iterating over. And this geometry is logical. It's all in your program, right? And as opposed to being running on the GPU, it's running on the CPU. It's just in your JavaScript code, right? And before each triangle is rendered, you may set some like global parameters that you want to pass to the shader. But otherwise, what the shader is really receiving as input is just the vertices, one vertex at a time. And what it will do is just transform the vertex from whatever coordinates came into it through memory into some other coordinate system. And the most common thing that we'll do with that is we will do something like a 3D projection, right? All of our vertices and points will be in what's called world space, meaning that they're actually sort of logically where the object should be in the simulation. And then you feed a scene like that into a vertex shader that is configured using your camera parameters. So at the start of every game frame, what you do is you take the world position of your camera and you crunch that down into a matrix. And that gives you an orientation or a perspective onto the scene. And then your vertex shader will basically move all of the points in world space and transform them into screen space. And the screen space is just like what's in the viewport.
Oh, that's actually the first time it's ever made sense to me, so thank you.
I'm glad to be of service. Yeah. So what happens at that point is there is implicitly in the OpenGL model, and I think probably DirectX works this way now as well, or it always had, is that between the vertex shader and the fragment shader, you are actually just drawing pixels on a triangle. And so you can imagine this like invisible outer loop around your fragment shader that is iterating over individual pixels in a triangle. And the coordinates that you get in the fragment shader are what are known as UV coordinates. They are barycentric coordinates, like a two-dimensional coordinate on a triangle. So coordinates you get are actually not in the space of the world or the perspective that you're in. It's in the space of like where you are relative to the triangle. So imagine just taking like one piece of geometry in your scene and just like laying it flat on a table. The coordinates that you get in the fragment shader are going to be relative to where it is along some notion of barycentric coordinates on a triangle. Because a triangle is like essentially a two-dimensional object, the UVs, it's basically, instead of an X and Y axis, you have a U and V axis. And the reason why this is important is for something like texture mapping. right? A texture, it basically gives you not something that looks like a triangle or a flat shaded triangle where it's all one solid color. It actually gives you texture. It's sort of like if you were to paint a model, it's whatever is painted on each flat surface on that model, right? And then what that allows you to do is use the UV coordinates of where you are physically on the triangle to basically decide what piece of a texture you want to actually render on that piece of the triangle, right? But then you can also do all kinds of crazy effects in the fragment shader, where you can also say, well, because the light is hitting the triangle this way, I want to know what light ray is hitting me right now, and then sort of modify the color from the texture based on the light properties and that sort of thing. So a lot of special effects that have to deal with color end up coming out of the fragment shader.
Gotcha. Okay.
Yeah, you mentioned something earlier called depth mapping, and
yeah, when you describe the depth it did, it's totally different than what depth mapping is, as I understand it. Where it's actually, I guess, a fragment shader, where it's like doing some amount of texture to simulate that based on like a second thing applied to it like applies a second texture and like tweaks it per triangle.
Yeah, that is a perfect description. So usually, I think the thing that I'm thinking of when you describe it that way is the bump map.
Bump map. Yes.
Yeah, so the bump map is exactly what you were talking about. It really, from a logical perspective, it's just another shader, or sorry, just another texture. And the way that you interpret a texture data could be that the texture gives you color, or it could be that the texture gives you some mathematical coefficient that you can run through a function on that specific pixel, right? So the notion of it being a coefficient is what I think like a bump map would be, right? And if you actually rendered a bump map as grayscale, because usually bump maps, they're usually they're on a 2D plane, but they only have one single value. So that's different than a color texture, because a color texture is going to have 4 different values on it. It's going to have red, green, blue, and alpha, if that's your color space, right? But a bump map is usually just going to have one number, right? And that's going to tell you how the contour of that triangle, right?
Right, and I've seen like the grayscale bump maps that get applied to a sphere to make it bumpy or.
Yeah, that's exactly right. So I guess this kind of goes back to your question about why are shaders such a pain in the ass? It's because they really are trying to give you super generic. It's a super generic interface. So
you can apply anything to anything essentially, and it just
exactly
in a pipeline.
Yeah, there's nothing magical about a color texture. It's just how you interpret the data, right? And that the fragment shader is where that all comes together. The fragment shader says, I'm going to take the bits from this memory buffer, treat it like a texture, and pull color information out of it. And I'm going to treat the bits from this other texture, this other memory buffer, right? And interpret that as like bump data or height mapping or something like that. And really, there's no such thing as a bump map in the OpenGL API. A bump map is just what you model inside the code of the fragment shader.
Oh, interesting. Yep. Okay.
Yeah. Okay, so bringing it back around.
Yeah. Let's get a square.
We talked about shaders, and the reason why we talked about shaders is that we might need shaders to render geometry because we're using a version of OpenGL that doesn't necessarily have a fixed function pipeline, or at least I haven't used it in WebGL before.
And is that ultimately we need a shader to tell us like the square is here or not? Like, please render that white, and it's actually going through a shader.
Yeah. Let me actually.
Okay.
Yeah, let me actually show you the shaders. And the shaders actually in this project are going to be like super simplistic. Let's start with the fragment shader. The fragment shader is amazing, right? So it's a .glsl file. It looks a little bit like C++ if you use it. And we've got some preamble here. I don't even know why we're declaring this thing, but it's a little bit interesting. GLSL, the sort of syntax in language design is perplexing to me, but you always have a main function. This is a separately compiled little piece of code that will basically get loaded into your GPU. And you pre-declare some output. But as far as I know, the fragment shader is kind of hard coded to emit this into a pipeline that just assumes that like it's going to be a vec4 to begin with. So why we had to say that it was a vec4, I'm not sure. There may be ways to say like, oh, actually this fragment shader emits a couple of different values and we're going to interpret them a certain way, right? So this shader is amazing, and let me tell you why. It's because the only thing you can get out of it is green.
Yep,
So it is like the
I
Model
can
T.
see it's green and it's opaque. Love it.
Yes. Yeah. So what Dom has sort of scribbled over there is a vec4. A vec4 is just the data structure we use to represent colors. We've got red, green, blue, and the alpha channel. Very good, sir. Now, it's coming back to me a little bit now that I do think that we can sort of configure the GL context to interpret that data in a different way. But I'm almost positive the same default to this would be to just treat everything that comes out of a fragment shader as the RGBA value, right? So this is not a terrible shader, actually. I'm kind of into it, right? So why don't we just go ahead and copy this for now? We don't have we'll use a different color just because we want to celebrate our newfound freedom. But I'm just going to call this the fragment shader.
Cool.
And there we go. I'm not going to worry about syntax highlighting on my shaders for now. Oh, you've taken over my cursor. You know what? That's amazing. I love it.
I just want to point out Tuple I turned on keyboard input, so now I'm typing on your screen too.
Yeah, I saw that. It was awesome.
Yeah.
So we've got the fragment shader there. Let's talk about the vertex shader really, really quickly, because this is the one I'm a little bit uncertain about. So
there we go.
Yes.
I have questions.
Yeah. Okay. So the vertex shader here is saying I am assuming that there's going to be an input vector that is in 3 space. That is essentially a world space position, an X, Y, and Z coordinate, right?
Okay.
And then it's expecting what is known as a uniform. Okay. And so a uniform is a value that you set from your program. And until you change it, every single execution of the vertex shader is going to use that uniform value. So that the word uniform means that it's like a consistent value that's being used, right? So in this case, we have a world model matrix and a projection view matrix. And what we're doing is essentially composing those 2 matrices together and then transforming our position vector, right? So I don't want to get too far into how matrices are used to sort of like manipulate vectors. Maybe we can do a linear algebra refresher, because Lord knows I need one.
Yeah, but essentially, like you can multiply matrices to get a new position out of it. So we've got our camera. Essentially is what we're calling our camera. Projection is the camera?
Yes. So the projection view is the camera, and it combines 2 things. It combines the position of the camera, and it also combines what is essentially like the field of view of the camera, and also the near field and the far field.
Interesting. Okay.
So there's this sort of complex idea of like a view frustum, and they like very generally speaking, it almost basically captures the sense of like a camera's focal length and its field of view, right? Not field of view in an aperture sense, because everything can be in focus in 3D graphics, right? We can have everything in focus. So it's but the focal length does affect a lot of different things. Projection also includes the concept of isometric versus perspective projection, right?
Oh, interesting.
Yeah. So perspective in art history is actually not something that we've had all the time. It's not like human nature, right? The difference between an isometric 3D view and a perspective 3D view is that in an isometric view, as things get farther away from you, like from your position or from the camera's position, they don't get smaller, right? So you don't have foreshortening. which is actually, I think, a super cool way to observe the world. And it's something that reads relatively intuitively um, for human beings, but it's definitely not natural, right? Because what our eye sees is if something's far away, even if it's large, it'll appear very, very small relative to something else when projected on a 2D. So that's what the view matrix gives us, right?
Interesting. Okay.
Yeah.
And essentially, we're taking what is like a camera representation and then a game space representation and saying like we've been given this point.
Yeah.
Here's how you get exactly where to put this on the screen. Like the
Yeah.
ending GL position is like given this and a single point in there. Like here's the dot you render is what's happening here, right?
Yeah, that's right. And I actually think probably when we write our own shader for this, we may want to break all these things apart because the projection matrix, the view matrix, the world matrix, and the model matrix are actually all discrete. The reason why they're mashed together this way is that I don't think it's free to change uniforms for every single piece of geometry, right? I think there is some cost to updating a uniform value in your program on the CPU and then having that value get shuttled over to the GPU so that it can run these shaders, right? Does that make sense?
That makes sense. Yeah.
Yeah. So really quickly, the list of matrices are from inside to out. You have the model matrix. And what the model matrix does is that our piece of geometry is actually going to be maybe like, I don't know, let's think about like a rotating wheel, right? The geometry that is like on one piece of the outside of a wheel is actually going to be relative to a sort of a center of gravity on the wheel, which is like, let's say it's the center of the wheel. That's usually the way it goes, right? And then another way you can think of that is like, if you are rendering a person has like a 0 point, a person has an origin. That character model then is going to have a bunch of like bones and sort of like character textures outside of it, whose positions are going to be relative to that center position.
Gotcha.
So the position that we're actually consuming in the shader is actually the position of that piece of geometry relative to the model. Does that make sense?
Yeah, but I'm not. Is the model matrix represented here? I guess that's what's getting passed in. It's already
Yeah,
relative position. Okay.
yeah. Well, I guess the thing is like maybe there's like multiple things. Imagine your arm, right? And let's say the position vector is where your elbow is, and then the model matrix is what the rotation of your elbow represents, and you're trying to render your palm or something like that. I think I reversed that perfectly. But basically, the model matrix accounts for any sort of offset any additional offset that we need to take care of if the position is not directly relative to the center of the model.
Ah, okay. Oh, that makes sense. Yeah, so
Yeah.
that's how you can take a T pose and turn it into a character that's doing a bunch of stuff. Yeah.
Yeah. Yeah. The world matrix is the same thing, but it's relative to, it's basically it maps the position of the, oh wait, I'm kind of talking about this incorrectly. The position that we're getting here, well, it's going to be from the geometry. So it is from the geometry. So it is like the position from the geometry. And then maybe the model is like basically placing, or the world matrix is placing that model in a position in the world, right? And I think why I'm getting confused is this is actually undoing all of these things. The reason why these are kind of like working backwards is we're actually taking something that is positioned out in a particular spot in the space, and then we're kind of crunching and compressing it all down into something that will show up on the screen. So we're actually undoing a lot of displacement and then like taking it out of 3D and putting it into 2D.
Right. Yeah.
So the world matrix basically compensates for the fact that a object might be really, really far away. So the world and model matrices, the way that you calculate that in your game is you're going to take the position of the player or the entity at that point, and you're going to construct a matrix out of that. And that's going to basically adjust the position, which comes from geometry, and place it into a point in space. So really what we're doing here with the world model matrix, we're not doing any kind of rotation or skewing or transform like that. We're just translating. We're really just moving the position around.
Hmm.
Does that make sense?
Yeah. So that would actually be like attached to like character movement if there was character.
Yeah.
Okay.
Yeah, exactly. So you have things that are positioned all over the play field, right?
Mm-hmm.
And then the view matrix, which is the next thing, accounts for the fact that the camera is actually in a physical position in the world, and you basically want to translate everything from being relative to the origin of the playfield to treating the camera as the origin, right? That's what the view matrix is for.
Gotcha. Okay.
And finally, once you've got that, then you can apply your projection, and then you can account for, because you don't want distance from the origin of the world to affect your projection. You want distance from where the camera is, right? Yeah. Okay, one more really quick thing before we get off the subject of what discuss, because we're not going to need any of this stuff to draw a box, right?
I was going to say, yeah, it's just identity at that point. Yeah.
Yeah. The reason why world model and projection view are combined the way that they are here is because world model, these two don't change relative to each other. This is like the position of the entity or the character, and then projection and view will not change unless the camera moves. So probably the projection view matrix is going to stay the same for the entire animation, for the entire rendering frame, right? Your camera doesn't really move when you're in the middle of that. However, the world model matrix will vary from character to character, right? Because you have a bunch of different like renderable entities distributed throughout your world, and they're all going to be in different positions and different orientations, right? Gotcha. They're going to be rotated or something like that. Yeah. Okay. So I'm not really sure what to do with the vertex shader. I think we just want identity. I think that's probably what we're going to want. Oops, I'm sorry. Too used to using swiping.
Oh yeah, no, it's gonna get you. You'll check out the stream later, but you'll see there's a whole bunch of JPEG artifacts show up every time you do that, and perhaps that'll teach you.
Yeah, it'll be a harsh lesson in reality. So I am guessing that probably what the shader can actually end up looking like is something like this.
Yep.
Right. Mm-hmm. What we see going on here is a little bit of GLSL magic, where when you do Vec4, it kind of is aware of the sort of thing that's going in this position, and it'll basically spread or splay what this position vector is composed of into essentially 3 different arguments to the Vec4.
Well, so we've gone from using Vec4 as a color to a position, but isn't a Vec3 a position in 3D space? What is our alpha channel for this?
So the 4th dimension is what is known as the W coordinate. And the W coordinate is, boy, I have to get into like normalized coordinates and all this stuff. Suffice to say that you typically represent 4 vector, like 3-dimensional vectors when you're transforming from 3D space into like a perspective view. You need to have like a 4th component to make this easy on the vector math. It's something to do with the fact that I think a perspective transformation is not strictly a linear transform. It's actually an affine transform, and there's just some gobbledygook reason why you need this extra thing. But it's been a while since I've actually claimed to understand the exact reasons for that.
That's fair. So this is, oh god, I moved the cursor and I can't even tell. So this is actually just going to keep it exactly. It's the identity. We're not changing anything. It's not going to be affected.
Yeah. So what often happens is that if this is not 1, like if it's 5, the x, y, and z coordinates will be divided by that value. Now, that's not a super useful thing for me to say because I'm not actually explaining the principle behind it. But suffice it to say, we have a shader that is the identity right here. We're just, whatever comes in comes out, right?
Yep.
Okay.
Yeah, I'm gonna look up the W coordinate myself because I've never heard that one.
Yeah. Okay. So carrying right along, we've got shaders. What we really want to do is like know how to use them, right? So I'm just looking at this, and why don't we go ahead and actually attach the shaders?
Yeah,
is that cool? Yeah.
Create program link. Yeah. This looks a lot like the MDN doc for setting up this thing for the first
Yeah,
time.
I think this is probably copy paste from that, which is a great way to do programming.
Mhm.
Um,
It's how
so
you
we
learn.
have a compile shader function.
Mhm.
Um, literally, the shader is just a string when it comes into our program. We need to compile it.
Mhm.
And then once we have that compiled binary, we need to ship it off into the GPU. And well, before that, we need to link it. So this is like we're building like a C program, right? We
Yep.
compile shaders, we link them. A full program is going to have a series of shaders. If I'm not mistaken, a shader also has as its property a type, so it knows that it's a fragment shader or it knows that it's a vertex shader.
Mhm.
I'm not 100% sure what happens if you have multiple vertex shaders. How does it order them? How does it compose their output?
That's a good
I guess
question.
we'll find out.
Since it's accepting an array here, I assume it's actually going to be in order that you hand it the shaders for whatever two pipelines there are.
Yeah, yeah, and so what it would mean to interleave vertex shaders and fragment shaders, I'm not sure,
Mm.
but maybe that's something we can experiment with. Um, now, I'm not even sure if link program here even loads the shader, but I think we can see because you can see that we're returning a WebGL program here,
Mhm.
and what that likely means is that we still have like another thing to call in order to actually get that program into the GPU itself. All right.
Yep.
So what we need is actually a way to get the source code of these GLSL files that we've gotten.
Well, parcel to the rescue because you just input
Yes,
them.
right. So what we have here is some import.
And the good TypeScript comment to teach TypeScript that those aren't really TypeScript.
Yeah. Um, and import is something that is what in CommonJS and in Node, but it actually doesn't exist on the browser, right?
Correct.
Yeah, and because the
Hasn't made it that
browser,
far yet.
yeah, yeah. Well, I guess loading separate files is something that people want to have a lot of control over in the browser, so they don't like this kind of thing, right?
Mhm.
But we don't care about that. We are actually just compiling one giant JavaScript file. That's what Parcel will do with all of our assets. So we have our fragment shader and vertex shader. I think I need to change the relative paths here because I've just dumped these at the top level, right?
Bingo.
Yeah. All right. And then we need to actually compile and link our shaders, right? So I bet we can do something like this. We're going to call link program,
Mhm.
and our program is equal to this.
Yep.
We're going to pass it our rendering context, and then we're going to pass it a pair of shaders, and the pair of shaders need to get compiled, right? So we're going to call compile shader of the GL context. The type, I believe there's a context. There's like a GL dot vertex shader. Oh yes, amazing. That's a good guess. And it is going to be vertex GLSL,
Mhm.
right? And then we're going to do the same thing with our fragment shader.
Nice. Okay. TypeScript looks angry, but is it about to be happy?
Can't find the name shaders. Did you mean headers?
Oh, it's not
Oh, you know
named
what I need to
parameter.
do? I need to do this, don't I?
No. I think you actually just want to take away shaders. It looks like it's accepting in a.
Oh,
It's
yes.
not named. Yeah.
Yes.
Just TypeScript. No object.
Do you find that when you do like React programming, where you use a lot of those like kind of ES6
Mm-hmm.
sort of like, I'm going to name the variable the same thing as the property of the object, that in some sense you've almost just like reinvented
The
the
parameters.
or just reinvented the parameter passing interface because like the name like the call site ends up looking like you're calling a regular function, right?
Yeah. Well, the thing that can I do it? How do I get up here? The thing that since you like Keith Rarick so much as well, he was just like never don't pass an object in. Maybe this was who else taught me that? But it's basically taught like every one of my JavaScript function signatures has turned into like, all right, well here's an object with a bunch of keys, so I can just call it like a bunch of name parameters instead.
Yeah.
Like
Wait,
what I
wait.
want.
Keith was against that or
No,
for it?
Keith was pro passing that in every time.
Okay, I'm
Yeah.
totally down to do that actually. I really like that style because I think over time, I mean, for this function, maybe it's pretty obvious what's going on. But anytime you get over like 4 parameters, you're just like, what the hell am I doing?
Well, and
Um,
for me, it's become at odds with TypeScript because then you have to define this like type. You have to define this object type in addition to your function type to be like this params is a link program params type,
oh,
which becomes like 50-50 annoying. So like I was doing that, and then TypeScript has sort of like started to beat that out of me again.
so does that mean you can't do like an ad hoc structure in the signature of a function?
It's you can write it. It's just really difficult to write.
Okay. Um, okay.
I think.
So that's actually something, like on balance extremely excited about TypeScript.
Yeah, we'll come
But
up with a house style. I think.
okay, that sounds good. Um, so we've got a program. What do we do with the program? I'm going to switch over back to the example.
Mm-hmm. My guess is that we run it.
We
Use
call
program.
use program.
Oof.
Amazing.
All right. So it's, and this is, I know JavaScript's fine with this, but I feel so strange that we're passing GL into functions that are just calling a thing called GL. Like we don't actually need to pass that context here. Probably in a different world we would, because GL is in our namespace above our functions in this file.
Oh, I see what you're saying.
I love that it works because I know it's going to work.
Yeah, I think I had copied and pasted this because this was maybe a piece of like library boilerplate or something like that.
We're gonna extract this, and GL won't be in a namespace above this. But right now, I'm just like, too many GLs.
Well, if you think about it, we actually did that in this sync viewport size function, right? We captured over the canvas object here.
Ooh, yes, you're right.
Yeah. So we're mixing our styles here. We'll figure it out.
Mm-hmm.
I feel the same itch that you feel.
We'll refactor off stream.
Yeah, I don't know. Maybe people will like seeing refactoring, right? All right. So what we want to do now is we want to add an actual triangle, right? Now, I'm not actually convinced that we need to go through all of this trouble. There's a lot that's going on here, right?
You're taking a mesh and you're actually turning it into triangles, right?
So this renderer here is actually quite complicated in that what it does is it actually renders lines. And the reason why I wanted to render lines is that we're doing like a wireframe renderer, and I didn't want the lines to be thinner if the object was farther away. So yeah. So you can't just like map a texture onto the triangle with like a little border on the edge of the texture, because that means the texture would get thinner and thinner and thinner as it would get farther. Right? That wasn't the aesthetic that I was going for.
Perspective takes hold unless we're using isometric cameras, which would be cool.
Yes.
Yeah.
So real quick on sort of the way that OpenGL processes geometry, I think similar to the way that we dealt with shaders, where there's just these like generic processing of vertexes and generic processing of pixels. Mm-hmm. Similarly, what you do is you pass these buffers of memory that have data into the GL context, and then you tell the GL context what they represent. And oftentimes the way that this works is you pass a bunch of points into GL, and you say, these are my triangle vertices, and they have 3 float 32s each. So that's all of my vertices in my entire friggin' world are all there. And then my geometry, so my meshes, so this is sort of like each individual object, my meshes are composed of these triangles, which are basically indicated by this other buffer here, and that other buffer has indices into the first buffer, right? So it's like almost like if you have like a series of three points that make up a vertex in your vertex buffer. Oftentimes you'll have another thing called an index buffer that says, now my actual triangles are 0.1, 0.3, and 0.5. That's one triangle. Another triangle is 0.7, 0.8, 0.9. And this is all just like stupid compression shit, right? Because like basically what it is that you don't want to repeat the same vertex twice if they're shared vertices, right?
Okay. Yep.
Yeah. So imagine like a pizza slice, right? A pizza whose individual crusts are like perfectly straight. So you're going to have like a 12-sided
Mm-hmm.
polygon, right?
Right.
And
Every vertex is shared by 2 slices and then one in the center. Yeah, that
yeah,
makes sense.
exactly. So that's the idea where you really have fewer vertices than you have. It's not just like 3 times the number of triangles. However, we don't
Ah,
really care about that, right?
yeah.
We just want to have like a triangle buffer,
Mm-hmm.
right? So I would like to actually see if we can do that. So we're starting really from the ground here. Now, all of the past things I've ever done, or I've done in the past that I've been playing around with, were mostly the sort of like vertex buffer, index buffer style. But I want to see if there's a shortcut around that, where if we can just pass in a buffer that's just like, here are our triangles. I mean, really, we have 2 triangles to make this,
Mm-hmm.
or even a quad, right?
I was
I
gonna
just
say,
want to give you the
do you
quad.
think quad's not real, or
WebGL, drawing a quad. Should we do it? Tutorials point?
I'm into it. Yeah. Once we get our quad, we'll go so much further.
Do not sell my personal information.
I
Opt
love
out
it
of
that
all.
I love it. That's the button they have to put now. Thanks, Europe.
Yeah. So these guys are doing the vertices and index buffer. I'm going to say for the path of least resistance, let's just do it and see what happens. Is that cool?
So they've made four vertices. Wait, so
Yep.
how is that 4 vertices though? Oh, I gotcha. Yeah.
It's a box. Yeah. Yeah.
I enjoy that the code formatting is part of how that has to work for this one.
Right. Yeah. So what we're going to do is we're going to make 4 verts: v1, v2, v3, v4, and then 1 triangle. You normally want to actually order your vertices clockwise if you're facing into the normal. So you'd say like 1 triangle is v1, v2, v3, and the next triangle is v2, v4, v3. Does that seem right to you?
Yeah, it's clockwise for this. I want my pen back. So that is this and this.
Yep. Perfect. Yes. Okay. So let's actually just, I think maybe this web page will have an example of how we actually put those in there. Oh, wait, we can just draw elements.
Let's just do this by hand.
Like this?
Yeah. Wait, where's the...
Where's the actual, where is it actually using the vert? Okay, so there's a bunch of junk here, right? They are doing the index buffer here. They are doing the vertex buffer here. Do you want to copy this? Just do that.
Let's see. Let's see what we got.
Okay. So just so we continue to have the visual aid there, right? Okay. So we've got our verts. Let's be disciplined about this. Let's try and do this ourselves. One thing I kind of don't remember. We are going to be looking down the z-axis if that's our camera orientation, right? And so.
And are they XYZ ordered? So.
Yeah. So let's do like 1/4. Let's do like the units are going to get a little bit confusing, right? So the verts are going to be something like 0.25. No, so it's going to be minus 0.25x, 0.25y, 0z, right? and that's v1.
Yeah,
And then
is
v2 is
0.25, 0.25, yeah. And then 0.25, negative 0.25.
and yeah, we could be super fastidious about aligning our things. Although I think probably if we're using code formatting, it might mess with us.
Let's get TypeScript to do that for us, or Prettier or something.
Yeah. You know what, Tom? Where's your sense of adventure? Okay. So I actually don't think Prettier would particularly do a good job with that.
No, you
but,
got to go even further into like write your own formatter.
Yeah, that's fine. I actually kind of hate doing any of that sort of stuff manually. I was just sort of joking around with that. So we're doing 1, 2, 3. Oh wait, this is 0 indexed, right? So it's gonna be 0, 1, 2, 1, 3, 2. That's what we wrote up here, right?
Yes.
Okay. And just so we're being consistent here, these are our triangles.
Love it. Yeah. So we're just teaching it to like. We're just gonna teach you like you get to 0 and you take 3 elements after 0 in the vertices array, basically.
Yeah, that's right.
Is just like this array of points. We're just gonna index this every 3 items and not worry about it.
Yeah. So what we're going to do is we're going to like load this and say that these are triangles, but you're going to get you're going to get the positions from this other buffer.
Yeah.
That's what we're teaching the context to do. So we create a vertex buffer.
Oh god, it's the same. It's the same thing, right? It's an array where you're just like counting every 3.
Yeah.
So OpenGL is just optimized for this at some point, where it's just like you've handed us 3 things in a row. We know.
Yes.
Triangle. Okay.
Right.
Or a point. Gotcha.
Yep. Buffer data. I'm not sure why it's unbinding the buffer like this. I think what it is so think of the OpenGL context as like one robotic arm and one thing on the table that it can actually operate on.
Yep.
And so what we do is we say that like when I call these like this buffer data function, all I can do is operate on the thing that we just put on the table. And we put it on the table using line 91 here. We say that here's the buffer that you just created. It doesn't have a name or a pointer or anything that we can use to kind of refer to it. So what we do is we stick it on the table, and then we do this operation. And the table happens to be named GL array buffer. That's what I think is going on here. Is GL array buffer is like the name of the location that we're updating. And so that's why there's this unbind here. It's to make sure that we don't clobber this object that was modified. Yeah.
Makes sense. And I wonder if there's a, I wonder if bind is doing any sort of, I was thinking it would have a concurrency check on there, but maybe not. Maybe it's really
you might be right.
Yeah.
You might be right in that, like, the reason why they do that is we're actually causing things to change in the GPU, and you don't want things to happen like all at the same time.
Right.
So we've got our index buffer. Although, you know what it is like, notice that array buffer, I may have misspoken. You notice how array buffer and GL element buffer are actually different identifiers. And I said before that those are our locations, but I don't actually think that's true. I think there's actually one buffer.
It seems like that's actually telling it what the type of the buffer is.
Yeah, that's the type of the buffer.
Yeah.
And there's one buffer that we can operate on at a single time. Yeah.
I wonder what would happen if you took out that bind to null, because it sure seems like line 96 should take care of line 93.
I agree with you. Let's play with fire, shall we?
Yeah, let's do it.
And then static draw, that's total mystery to me. I'm not sure what it's doing.
Great.
I can compare it to my renderer here. When I did bind buffer, I was also doing static draw. Congratulations, Jeff. You have you have done what tutorials point has done.
Wonderful.
Right. We have already sort of done our shaders, right? They're kind of inlining them here. And then their vertex shader. Oh, look at that. It's doing exactly the same thing that we did.
Love it.
Right. Oh, God. And then we have to do a vertex buffer object. And the purpose of this is, well, let's just try to analyze this.
Mhm. So where are we getting those? VBuffer and iBuffer are not the same. Is not the same as vertex buffer and index buffer, or did you rename that?
I just renamed them
You
because I
renamed
didn't like this person's sacrilegious snake case in a
I think
JavaScript world.
I know I like that. In fact, they made two different choices. They're like vertex camel case buffer and for some reason heads up snake case index buffer.
Yeah. Right.
So wait, so why are we binding these again, and why are we binding two in a row? I have questions.
So let's just get rid of these and see what happens.
Great.
Right? Because it seems weird, right? We unbound the buffers above,
Mm-hmm.
and now we're rebinding them.
And the fact that you can bind two at the same time disproves our theory that they're like a single buffer you're working on.
Yeah, maybe that was the location thing that I was talking about.
Mm-hmm.
All right. So vertex attribute pointer. Okay, so what this is doing is saying we are going to take the position variable in the vertex shader, which is this one.
Mm-hmm.
And that is going to be fed by, where's chord coming from? I copied this, so
it's the assignment right here.
Sorry, yes, of course. So this is like the address of that value in that shader, right? You can think of it that way, or it's like that particular register or something like that.
Gotcha. Yes, we've got a pointer to start feeding data into the coordinate, which should come out of these buffers. Like
yes. So all we've done so far is we've said that this value here is going to be populated by a vertex buffer of some kind that we've yet to specify, right?
Have we even specified it's a buffer? We've just like gotten a pointer to it.
Yeah, but see the line on 100 here says enable vertex attribute array. So what we're saying is that the shader is going to be iterating over that array, basically.
I see. We've said yeah, we're prepping it to iterate over values and drop them into coordinate. Okay, sure.
Yeah, and what's funny about this is, in a certain sense, it almost seems like we're double specifying what that coordinate parameter is, because it was a vec3 inside of the vertex shader, but we've also stated it again here in this GL vertex attribute pointer kind of thing.
Yep.
So not very dry. Good job, OpenGL API designers.
It's not my experience with OpenGL at all, so we're good. Yeah. We're getting there. I see it.
We are getting there. We don't need to enable the depth test per se. We've got the clear color already. We've already cleared that. I think we just need these last two lines.
Yep, which is okay. So the GL viewport is actually in pixels. Are we gonna draw a half pixel square?
So the viewport here is the physical size on the screen.
Okay.
And then this stuff is world space coordinates.
Okay.
And how that actually is going to get translated, I'm not sure. I think by default, these are what are known as normalized coordinates. Mm-hmm. I think that is essentially how, like the pixel coordinates, like all the stuff that gets like projected into your screen space is going to get projected into a space between -1 and 1 on the x-axis and -1 and 1 on the y-axis. Mm-hmm. Okay. So I think this is just going to be around the center of the screen.
Yeah, that makes sense.
So
I'm trying to see if there's anything that was setting the like. Yeah, nothing's really normalizing that. So we'll find out how big it is.
Yeah. And will it be a square, right? What is sort of
that's a great
making it proportionate? Yeah. I think it knows. I think it actually knows. Mm-hmm. So draw elements here is saying we are treating.
We're giving it
I think this is. we're treating the index buffer that we just created as triangles.
Mhm.
There's going to be this many of them,
Mhm.
and their type is an unsigned short. This is the stride. This is like how big is every element in
Yep.
this array that we're passing in there. This is a very C-oriented API, isn't it? It's just like, we don't really
Yeah.
know how big something is. We're going to send you a void pointer. This is how long it is.
Well, and
And
it's
this
interesting.
is,
We're telling it that there's 6 triangles, or it's kind of figuring that out from this somehow.
um,
But
it
but
knows that each triangle needs 3
Yep.
indices.
Yep.
Yeah.
And so interestingly,
Um,
the vertex buffer isn't actually connected to anything here, but is it the fact that we've bound an element array buffer and an array buffer and then handed it something that looks like that it knows to deal with that?
that is a very good question.
I feel like this and this are maybe some magical like draw elements things that are happening, but that's weird.
Right. We have painstakingly set up all this stuff, but there's still some lack of explicitness here, right? Like maybe it just knows that the array buffer is where
Like
um,
like GL array buffer and GL element array buffer are constants.
yeah, maybe it knows that this is connected to the array buffer, and maybe it knows that this
Yep.
is connected to the element array buffer, something
Yep.
like that.
When I specifically I feel like since indices is showing up here and here, that like it must know that like draw elements knows to look for the element array buffer somehow.
Yeah,
And that's fine.
completely. And you know, like I actually think to really hammer that home, maybe visually, what a better way of visualizing this is something like this. And then we'll just take the viewport thing and like
can we
move it up here.
Maybe right below the GL clear. Oops.
Maybe after that. It feels like
Sorry,
you'd
yeah.
want to set the viewport after you clear.
Yeah.
So something like this, maybe. I mean, we could really get rid of this function entirely, right? Let's just chuck all this crappy code. Don't need it. And then this feels like a complete breakfast here, right?
Do you want to see what the browser's been rendering in the background?
It's going to be like completely plain. Oh my God. It is there. Holy shit.
It's sure ain't a square.
It is not a square.
But wait, I know how to make it a square. We got this. So close.
That's working. So we are missing some form of transform, right? Mm-hmm. It feels like we need to transform this by the dimensions of the viewport.
Right. Yeah, we need to. Or is this we need to teach it what a camera is, or like what its viewport is? Like we're looking into normal space.
Yes.
With this thing that's actually wider than a square.
Yeah. So you know how I mentioned those normalized coordinates. So like essentially it's just 2 units wide and 2 units tall, and the triangle is what, half a unit wide and half a unit tall, right?
Yep.
So I believe the renderer that I wrote maybe accounts for this. Let's check this out. This is all. Oh, you know what it is? I think you're absolutely right that the vertex shader needs to compensate for this.
Oh, that makes sense. I mean, it is the thing that we took the universal uniform. We took the uniform out of that. Yeah. Yeah.
So let's try and reverse engineer this.
Set a uniform.
We can set a uniform. Although we erased that code, so we got to get that shader code back. Right. But when we call resize canvas on the renderer, we are telling it a next canvas size, and we are setting. Oh, this is just if you resize, but it's still not accounting for. What are we doing with the canvas size in here? Ah, aha, aha. See all that?
It has a aspect ratio.
Yes. So the perspective itself bakes the aspect ratio in there. That's great. What compensates for that.
Love it.
Now, I actually don't want to get into the business of the perspective matrix because we don't actually care about a perspective projection right now, right? What we really care about is just making sure that we're compensating for the aspect ratio
Mhm.
in some way, shape, or form. So is there a way that we can just pass a couple of floats into the shader and just like divide the x-axis and the y-axis by something? Does that seem somewhat reasonable?
I'm intrigued by that. That's
Okay.
yeah.
Um, all right.
I wonder.
So
I wonder if
yeah.
there's an MDN doc on this too. If there's like a, I wonder if their quick render has a we did this for you. Not that
Yes.
I don't want
Or
to
let's
exploit
actually
it.
take a look at this. Um, look at these
Nope.
assholes.
They just drew it in a
Um,
square.
they just drew it in a square. Yeah.
So here's an even
Yeah, they
simpler
totally did.
thing. What if we made our
Yeah.
canvas a square today and made the box bounce
Okay.
around?
That is very, very intelligent here. So why don't we do this? Let's just do 800 by 800. Is that
That
too
sounds.
big?
I think that'll be great.
Okay.
Yeah, because like let's do some movement too. That'll be a lot nicer than messing with camera stuff.
Okay. Fantastic. How do I center this?
CSS. Margin zero auto, Flexbox, one of those fun things. Yeah, do it. That's it.
Oh my God, we are hackers. It's too tall for my screen. I'm gonna reduce the size.
600 by
Sorry, I
600.
can't handle this. Yeah,
That's okay. That's okay.
I'm just retreating with my tail between my legs. Um,
Well,
oh my God,
it's
yeah.
perfect.
And then it's probably Flexbox if you want a vertical center. I'm not going to bother with
Nah.
that. Fantastic. It like took us, I think, 20 years of the web to be able to vertical center, right?
And now I do it all the time, and I'm just thrilled. Uh,
Okay,
so
this thing is way too big, right?
I want to go back to the vertices real quick. So
Yeah.
this is oops.
Yep.
This is half of a point of whatever our units are.
Mm-hmm.
Oh no, God, I've got too much control. I just wanted to go to the press. Great. It's half of a point, and that half of a point is this like 1.5 wide? Do you think it's actually too wide? Or sorry, 2 points wide instead of. I'm trying to figure out like how did we end up with this?
Oh yes. Let me try the QuickTime thing and draw a picture. Shall
Oh
I do
yeah,
that?
do some math. Yeah, yeah.
Yeah. Okay. So let's see what's going to happen here. I believe you stole my cursor.
Oh,
Um,
that's so like when I move, it takes your cursor for a second, then when you move, it comes back. This is
yeah, I'm not
wild.
really sure what the deal is. Okay, so the camera that we're going to be using is the iPad here. It's going to get a little bit fractal.
Ooh, good stream.
And there we go.
Nice.
Um,
What app is this? It's a nice app.
this is Notability. Check
Okay.
this out. I can draw a square and hold it here, and
Mhm.
it'll like normalize the shape,
Oh,
and I can
dude.
erase it, and everything's vectorized, so I can say hi, Dom, and then erase letter by letter.
What? All right, that's very cool.
Yeah. So okay, our normalized device coordinates on a screen. You have your origin here,
Mhm.
and this is -1, 1, and this is -1, -1. This is
Okay.
1, 1,
So our screen is 2 units wide in this
and
default.
this is yeah. So what we did is we created a
Gotcha.
square where we
Cool.
have -1/4, 1/4 right here, right?
Yeah, maybe it was just a trick of the actual perspective where it feels like that's not too across 2 units wide, but maybe it's actually just because it's centered and it feels kind of funny. No, you're right. I can see it.
Okay, I know exactly what you're talking
Yeah,
about. Actually, it feels smaller than it should be, right?
I feel like I couldn't fit 4 squares left to right on that, but I bet
Yeah,
I actually probably could.
right.
Cool.
Okie
Okay,
doke.
and we have exactly -1 to 1 to work with. That's great. That's really comfy.
Okay,
So
so
yeah.
now we want to actually move this sucker, right?
Mhm. And did you want to make it a little smaller?
Yeah. What do you think?
I think. Ooh.
You can you do Command Command D on this and just replace them all.
That's what I was trying to. That's what I was trying to do, but I'm discovering that in fact,
I can help you type. I've got the
yeah.
keyboard right here.
How about let's just make it Command D and then like 0.05 or something.
So we're making it quite a bit smaller.
Yeah.
And that is perfect. That is beautiful. Right.
Yeah. Something about tuple is not super happy once I start taking the cursor, so maybe we got to troubleshoot that a little bit.
Okay. No problem.
Yeah.
All right. So now we got to change gears completely and talk about the simulation itself. Right.
Mm-hmm.
Get a little wild here. Okay. So let me just write a bunch of code down here. Right. So we have an x and y coordinate, right?
Mm-hmm.
And it's going to be at the origin, right?
Right.
And what we would like to do is we just like to move it around until it hits the edge, and then have it bounce, right? So we're going to have some loop. Probably will never end, right? And we're going to have some velocity, right?
Mm-hmm. For velocity, are we going to have a impulse of any sort? Like, is there a... Oh, okay, we have velocity in two directions, yeah.
Yeah. So this is kind of our really basic entity structure here. And we're an ES6. I can do this, right?
Damn right.
Look at that power. And let me just slim this down even more. Hopefully this is another like thing I learned from Keith Rarick, which is to use short variable names. Drives some people crazy, but
you know, if it wasn't actually representing X and Y, I would complain.
Yeah, I feel you. I mean, these will be vectors eventually, right? We'll be using sort of vector data structures to represent a lot of this stuff. Yeah.
So we need to basically we have a point and we have a vector. That point is moving like its velocity, and we need to apply it to our vertices matrix to decide where it's actually running on the screen. Is that what's coming next?
Yeah, that's right. So what we have here is like a really elementary game loop. Mm-hmm. And what we'd like to do is something like this, where we say x equals x plus vx times some time, mm-hmm. whatever that will be. If we want to have a fixed frame rate, then we don't care about that, right? Every update we assume is the same amount of time. So let's just do that and then figure out the frame rate issues later, right? And then y equals y plus vy, right? Mm-hmm. And I bet we can do this in such a way that if we set this number like really, really low, we can make this thing animate. That's probably too low. But what we want to do is, I don't know, do we want to simulate this first just with like printfs or console logs or something like that? We can do like console.log.
Yeah, you want to see it hit the edge and then like turn around, basically. Like we're trying to...
Why?
And in fact, I guess we do this, we hit an edge, and then we negate one value based on whether we've hit one on X or Y, essentially.
That's exactly right. So I bet this is already running, and it's probably going insane. Whoa, what happened to my... Oh, you know what? Sorry, I keep changing. I have this reflex.
You know what's happening?
Web page flowing down your browser.
It's doing too much.
It's doing too much. Okay, so there is a callback, right? Like render animation frame or something like that that we can do.
Yep, I think we probably need to, because JavaScript hates that infinite loop thing.
Yeah. How does window get? Okay. Yes.
Request animation frame, or yeah, something like that.
Yeah, I think it's actually in here. This is not a bad way to do it, actually.
That's cool. So wait, does that just...
Sorry.
No, that's okay. How? I haven't used this before, but like, what is that doing?
It's like set timeout. So if you do set timeout here, right? Something like that. It's just like call myself in 5 seconds.
Oh, I see. So you start the function and we say call me again for the next animation frame. Gotcha.
Yeah, I think what's confusing here...
I thought it was
Sorry,
blocking.
go ahead.
No, I thought it was blocking until the next frame was ready, but that makes much more sense. It's actually just queuing it up, and then it's like, and I'm going to do some work after I've queued up my next call.
Yeah. Yeah. So if you do this, it still might be too much work. We'll see.
This might give us a fixed frame rate though.
As long as we're not slowing, as long as the browser itself is not getting slow, right?
I think you have to stop it. Yeah, it's probably unhappy.
Stop it.
I've had to kill the tab and start over.
Oh, you know what? This is the wrong thing. Anyways, sorry. I'm just bad.
There we go.
Okay, there we go.
That's super reasonable.
Okay.
Cool.
Totes. All right, we want to simulate a bounce, right? So I think it's exactly as you said, right? So if we say if x is greater than 1, then Vx, reverse it.
Yep.
And if, or it's really if -1 is less than x, right? If we're sort of like, actually, I'm not arranging these correctly. I like to have like if x is less than -1, or
I think you just want if
1 is less than x.
math.abs x is less than 1. So like we just want it, if it hits a threshold, we just want the absolute value of x to be less than 1.
Okay, that sounds good. Yeah. Math.abs of x is greater than 1.
Yep.
Similarly for y, we want to reverse it. Yep. Okay, so if we go back to...
you gotta get the vy in there, but yeah.
Oh, I'm sorry. Yeah.
That's okay.
Pair programming. Awesome.
Love
Thank
it.
you.
Did we crash your browser? We crashed Firefox. Something crashed Firefox.
It is gone.
Great. Let's open it here. It probably had one of the tabs that was still just spinning in the background forever until it ate all the memory.
Okay, so this should give us a kind of oscillation if I had made it go faster, right?
Yeah, well, and in fact, I think this is, since we started in the center, we're going perfectly in one direction or the other. It's just going to bounce from corner to corner, right?
Yeah, and that's fine, right? So we're going to go 10 times faster.
Beautiful.
It's negative, positive.
Yep.
So it seems like it's working. But for the purposes of not killing my memory here, I'm going to stop. There's no reason why it should be leaking, but I don't know.
Maybe you had a tab that was still doing the infinite while loop.
Oh, okay.
On the other screen, yeah.
Oh, yes, that's absolutely right. And so it crashed the entire program.
It crashed the whole file, yeah. Which it's not supposed to, since they're supposed to be threaded, but like browsers.
Yeah. I actually don't know the architecture of Firefox is supposed to be super clean, right? It's written in Rust and all that.
It's supposed to be.
Yeah, supposed to be. So at this point, what we want to do is just actually have this show up on the screen, which means that we need to actually apply this to the vertex positions, right? So one of the ways I can think of doing that is just simply adding it to the vertex position, right? Let's just take our x and y vector and add it to the vertex position. Does that make sense?
Yeah.
So if we look at the shader, maybe we have like a uniform vec3, and this would be our kind of like world coordinate. And what we would have is maybe, I think we can do this.
Oh shit, dude. That's really cool. Okay.
And then what we would do is we would say that like our world matrix is something, right? It's going to be like x, y, 0. And then we need to get that to the shader, to the shader somehow.
Right.
So let's talk about that.
Now, does GameLoop need to actually wrap up all that rendering stuff in the first place?
It does.
Yeah.
It does. Right. Well, not all of it. I actually think the buffers don't need to change, right? The buffers can be set once, and we're golden there.
Because they're the same, yeah. But the draw elements is probably what needs to be in the GameLoop.
Yeah. Now, if we had a thing where we were like destroying entities and creating them, which is what games do,
Hmm.
then we would probably care about like maybe refreshing the buffers during the game loop, right? Um, okay, so how do we get a uniform into a vertex shader? I think it's this here. Get uniform location, and then once we have that uniform, we set it using. This is like an address here. We grab the address using get uniform location.
Gotcha.
The function tells us what the thing is,
Hmm.
and then we pass in the thing from CPU space. That's what this world model thing is.
Okay, cool.
Yeah. Okay.
And
So
somewhere in there, there's just a false. Just false.
yeah, that's just it's just
Just
false.
in case, yeah.
Yeah. So this uniform is actually called what do we call it? World.
World.
And we're not object oriented right now. This is just all
Mhm.
local. World.
Wait, no, we need the.
Oh, I'm gonna pass this in as like maybe a literal,
Oh, yeah.
or we can call this world uniform.
I like that.
That's
I like knowing that it's an address.
Yeah. And then we do this. Are you semicolons or anti-semicolons these days?
Anti.
Anti. Okay, I'm gonna stop.
I need them for exactly one purpose, and it's like when you have to do those weird like I'm doing an inline function, but it can't figure out that it's like not starting a new function. But otherwise, like I just write code that doesn't need the semicolon. Cool.
Yeah, sorry.
No, it's great.
Uniform 3F.
Uniform.
I think that's what it is. 3 floats. I don't know what the V is, but and then the signature asks for 4 arguments. And it's not going to tell me what they are.
Oh, it wants X, Y, Z. World address X, Y, Z. Argument for Z was not provided.
So it really wants, world uniform X, Y, 0. That
looks good. And then we just draw elements. Wow.
I think we need to put the clear as well, or else erase stuff, right?
Oh, will it keep the previous one? Is it going to be like the Windows like bouncing solitaire cards?
Yeah, I think it'll accumulate.
I want to see that. Render that sucker.
Oh, I didn't do the animation loop thing. Sorry, I commented that out.
I think you can keep that running. I bet that's fine.
Okay. Holy shit. It's not black, but it is clearing it out. That is really interesting, isn't it?
And wait, did it stop animating? Or is my screen just slow?
Okay. Your screen might be a little slow. Sorry about that.
No, it's okay. It's interesting. I think as soon as your computer starts rendering GL, we have some sharing. Oh, there we go. That's dope. Why is it white? That's so interesting.
Yeah. I don't know why. Oh, you know what I did? You know what it is? I cut the clear. I removed the clear. What happens if we do this here? Oh wait, I didn't cut it, did I?
No.
Let's go up. The clear color's here, but for some reason it's going to white. So there's something outside of our purview that's just like clearing it back to white. I wonder if it's the animation frame. But if I do this, I bet it's going to do what we want. Yeah.
Sweet. Look at that animation.
Yeah, and then to make it really sticky within the borders, I think what we want is something like constant size equals 0.05, right? And then let's do size here. And then down here, let's do 1 minus size.
Yep, exactly.
Oh man. I would be doing the sort of like pointing at my eyeballs, pointing at your eyeballs thing if I could actually see you on my screen, but I don't.
Oh man, I'm sorry. You know what? You could put my face right behind in the bottom. If you put it in the bottom right corner, it's probably behind your face for me, so there won't be a white box on the screen.
Okay, maybe for next stream.
We got some
Let's
streaming updates to do. That's great. Okay, look at
let's
this.
add some jazz riffs to this. We're gonna get like just 45-degree bounces. That's okay, but maybe let's do yay and see what happens.
Look at that. This is.
We have a video game.
Can we change this to the DVD logo and the game does it hit the camera or not? Oh, so close.
Yeah. I
Looking good.
This is super dope, isn't it?
Yeah.
Um,
So we have an OpenGL context that is rendering two triangles with a velocity that we've determined based on. Can we make this user input? Can you put a little thruster button in there or something?
we definitely can.
Yeah, because I guess it's just JavaScript, so we can actually.
So you want to sort of accelerate. You want a sort of an acceleration here, right?
Actually, I guess can we just can we change this to is key down and use the arrow keys and actually just move the square around? Because really, we just want to have if is key down, add velocity x or velocity y to the position based on whether or not you're holding the arrow. Yeah.
We can totally do that.
Yeah. Because that's cool. This is already cool.
This is dope. I'm very excited. So how did I do keyboard? There's a keyboard right here. And
I mean, this should be the boring JavaScript part. Yeah.
I just kind of create the keyboard and it adds a bunch of listeners. I don't need the rest of this shit, right? Okay, so our input handling, I'm just going to chuck it right here, right?
Love it.
So this gives you super value add because it's if you focus out, it'll clear all the stuff. So you're not pressing stuff down anymore. I think this is actually important because I believe if you focus away, it'll just remember your last input and just assume that it's still held down, right?
Exactly.
Yeah, this is a const. Okay, and then what we're going to do is, I do not know off the top of my head what the key codes are for arrow keys, but we can find it, not here, but perhaps here. Camera control, yes? Oh yeah, check that out.
Oh, nice. Cool.
Yeah.
So we just want up, down, left, right there.
Yeah.
Nice.
So if key down dot up, yes?
It's a set, so it needs to include.
Oh, yes, we need to do an inclusion check. How do we do that?
This is
so
basic JavaScript that I can't remember. Is it just dot includes?
Has.
Wait, really? Oh, it's a set. I've never used a set.
I mean, I could have programmed this a different way, obviously. And then up is keymap.up, right? Then we will add the velocity, right? Else if key down dot has keymap down, and I've got this is actually right, left.
Oh, yep. Good point.
So we no longer have bouncing here, but we can do collision, some really jank collision detection here. At least we can prevent it from sort of bumping off the walls. How's that sound?
Exactly. Yeah, we should max it out at the 1- size.
Yes. So how do I used to be able to do sort of boundary functions. So, but basically what we're saying is
clamp, math.clamp.
Is there a math.clamp?
No. I wanted there to be.
What is clamp? Let's do clamp really quickly. We can do this. We can do this, right?
Yeah.
Clamp v, which is a number, min also number max, also number, and that gives you number. Is it just two ifs? I feel like we can do better than that, right?
I think it's just two ifs though.
Okay, if okay. I think you can combine min and max together cleverly, but that's probably maybe too clever. If v less than min,
Yep.
yes.
Yep. Looks good.
That's 1, 1.
And then minus size. Minus size and
Oh,
plus size on one side of that, but yeah.
yes. Plus size.
And then one minus size, yeah. Sick.
Oh, we are computer hackers done.
All right, left and right, and it's gonna move diagonally. Do it.
It's not happening.
Oh,
Not happening.
I think because you mapped it to Q.
Oh,
You're up, down, left, right, or WASDA.
oh. Well, no. I see what you're saying.
And also the Y is mapped to left and right as well, so it's doing A and D are handling left and
So
right.
what I want is for this to be up, and I want this to be down, and I want this to be left, and I want this to be right. Right.
Correct.
Okay. I can move it kind of diagonally.
It's because the Y movement is also mapped to left and right instead of up and down. We didn't change the key code.
Oh.
That's what you got your pair buddy for.
Would have taken me hours to debug that, I think. So the x velocity seems much spicier than the y velocity. You try it.
It is. Oh yeah, spicy is a good word for that. I actually want somewhere in between. Like I think I want 0.02 for both of them.
Okay. So why the discrepancy?
Because we set 1 to 0.04.
Oh.
We did that to ourselves. It's
yeah.
VX.
So let's do this const v equals 0.02, and this is all just v. Oh.
Right, because now it's not actually a bidirectional thing.
Yeah. It's really just speed. It should be called speed. And our diagonals will be extremely fast.
Our diagonals will be extremely fast.
Yeah, because it's Pythagorean theorem, right? Like.
Oh yeah.
Yeah. So we can do sort of like maintain constant linear velocity if we sort of did some square roots in here. If we wanted to.
Interesting. Right.
But this is the way that a lot of Nintendo games would control, I think. You tried.
Yeah, I see what you're saying. That does feel actually much faster, and that makes sense because we're moving more. And I guess it's here because it's in fact it's the
we're moving the square root of 2 if we have both of them pressed down. Jeff and Dom have made a video game. Look at that.
We did it, and we're 7 minutes short on our 2-hour stream. So good job.
Yeah, nice.
Dude, this was fun. Should we maybe take the last 5 minutes? What do we want to do next week? I can research stuff in advance.
I'm happy to talk logistics after the stream is over as well. We could terminate early, or we could do some extra credit here. I don't know what we'd do. One thing that in my imagination would be really cool would be some kind of shadow or trail behind this thing, but that strikes me as maybe a little bit complicated to do. We'd have to have essentially a history of objects, and as we iterate over that history of objects, we change the color a little bit, right? So it's maybe a couple of steps. Maybe that's something we can do for next time, something like that.
That sounds fun. I'd love to make a little trail like that. So that sounds cool. Also, we can maybe revisit in fact that we wanted to do breakout and not mouse control. I just really wanted to put some keyboard controls.
Yeah, yeah, awesome. So maybe we can close the stream out for today. Next
So,
stream ideally will be Saturday morning sometime. We still have to figure out the timing.
sounds good.
Okay.
So
All
excited.
right. Stay safe, everybody.
All right.
All 0 of you.
All right. Oh, the stream is now fractal, and I'm going to hit stop. Goodbye.